In example 10, we've got a space shuttle and we've got its time of liftoff is time 0, and the time where the rocket boosters were jettisoned is at 126 seconds. They gave us a function for the shuttle's velocity, and then they're asking for the absolute maximum and minimum of the acceleration. So the first thing I need to do is find the acceleration. And then to find the max and min, I need to find the derivative of the acceleration to find my critical numbers. And then I'm going to plug in my critical number. I'm going to plug in my critical numbers to the acceleration function. I'm also going to plug in my endpoints, which is going to be 0 and 126, and figure out what's the highest and the lowest acceleration. So first, I want you to notice that it gave you a starting time and an ending time. So this is giving us that closed interval from 0 to 126 seconds. Okay. Then from there, like I said, they're talking about the acceleration, and what they gave us was velocity. And we know that acceleration is the first derivative of the velocity. So I'm going to do derivative of velocity and get my acceleration function. And so if I do 3 times the number in front, I get 0.003906 t squared. Take 1 away from the 3. If you multiply it by the 2 in front, you get negative 0.18058 t to the first, because you take 1 away. Then derivative of the 23.61 t is 23.61, and derivative of the negative 3.083 is 0. So that is my acceleration. We want to find the max and min of the acceleration. So I want to know, when does the derivative of this equal 0? Because that's where max and mins are going to be. So we're going to find the derivative of acceleration. So I'm going to multiply by 2 in front, and I get 0.007812 t, and then minus 0.18058, and then plus 0. And we're going to set this equal to 0 to find the critical numbers. And so what you're going to do is add this 0.18058 to the other side, and then divide by the 0.007812. And we ended up getting a time of 23.12 seconds. This is going to be my critical number. So that could be a maximum or a minimum. We don't know. So what we're going to do then is take the acceleration function, because I'm looking for max and min of acceleration, and I'm going to plug in my 23 that I just got, the critical number I just found, and I'm going to plug in my endpoints, the 0 and the 126. So when you plug in 23 into this function that I put a box around, you end up getting 21.52, and that is meters per second squared. When you plug in 0, you end up getting the 23.61 meters per second squared. And when you plug in 126 for these two t values, you end up getting 62.87 meters per second squared. So your smallest one is at 23 seconds. That is your absolute minimum. And then your largest one is at 126 seconds, and that is your absolute maximum. And so what we just saw is this space shuttle has a minimum acceleration of 21.52 meters per second squared and a maximum acceleration of 62.87 meters per second squared.